Today we're going to pick up where we left off yesterday. Yesterday we went through a bunch of information on how to recognize without having to do a whole lot of calculations the difference between the parent function and the new function. And today we're going to continue that, following up the absolute value problem with transforming a square root parent function. So we're going to start off with this square root one, and as I mentioned a little bit yesterday, the big thing with the square root function is, as you can see, I don't have anything other than 0, 1, 2, 3, 4. I don't have any negative values. One thing that you might have recognized by now is that when we do square roots, you can't take the square root of a negative number. You'll be able to get into that in calculus and maybe a little in pre-calc, but those are imaginary numbers and we don't deal with those in Algebra 2. So because we don't deal with them in Algebra 2, we're going to start off with just positives. So I'm going to start by filling out the first part of this table. Square root of 0 is 0. Square root of 1 is 1. Now square root of 2 is not pretty. I'm going to put an estimate here, which is approximately 1.4. And I'm going to do square root of 3, which is approximately 1.7. And the square root of 4 is 2. So let's go ahead and graph that now. And I've got my points already pre-made here. So 0, 0, 1, 1. Then we've got 2, 1.4, which these numbers are going to start to look kind of similar. And then 3, 1.7, and 4, 2. And in doing that, now I can connect my dots, and you'll see that it looks like half of a parabola. And that's exactly what we're looking for. So now we need to start looking at this new function. As you can see, with this new function, we've got this -4 out in front. Now, if you recall from our information we took down in our notes yesterday, when we have a number out front, that tells us that we have a vertical, either stretch or compression, and because that 4 is bigger than 1, we know it's a stretch. So I'm going to go ahead and put that information into our verbal part and mark that we have here a vertical stretch, and I'm going to abbreviate vertical stretch, and because it's a 4, that means that we have a factor of 4 that our vertical stretch is being made. And if you recall, vertical means that we're going to factor in on our y values, so I'm going to put in here times 4 so I don't forget. And then that second part that we have in this problem is the fact that it's negative. Now, that's the thing with vertical stretches and compressions. That coefficient is never going to be negative, which means we're leading to something else. And the only thing we actually dealt with yesterday in our notes that was negative was if you have a reflection. And as you can see, this negative is out in front, which means that it's going to be a reflection across our x-axis. So please feel free to use those notes as a comparison so you have that information for you. So I'm going to write down that we also reflect over the x-axis. And so by doing that, that means that all of our y values are going to be negative, because if you think about it, the x value stays the same, the y value is what's going to go to the opposite. So all of our x values are actually going to stay the same. So I'm going to go ahead and fill that out and say, well, you're still going to be at 0, 1, 2, 3, and 4. So we're going to first take our y values, we're going to take them negative and multiply by 4. So 0 negative is still 0 times 4 is still 0. 1, make it negative, is now negative 1. And that is going to be times 4, which is negative 4. And 1.4, this one gets a little bit trickier. We will take one negative, so we know it's negative, and times 4. 4 times 4 is 16. Carry 6, carry the 1. 4 times 1 is 1, plus 1 is 5, so we have about negative 5.6. And I'm going to put the approximate here and here because we know that's not exact. 1.7, we know it's going to go negative, and times 4, 7 times 4 is 28. Carry the 2. 4 times 1 is 4, plus 2 is 6, so we have about negative 6.8. And then 2 will go negative times 4 is negative 8. So now we can go ahead and graph this. So we start off with still 0, 0, so we'll put our red dot right here. It's actually going underneath, which is okay. We have 1, negative 4. We have 2, negative 5.6. We have 3, negative 6.8. And we have 4, negative 8. As you can see, this is going a lot wider, and so therefore it's going to arc out like the other one did, but a whole lot slower. So we'll go ahead and we'll connect those dots right from the origin, and we'll keep going this way. So there you have it. We have our first one. Now we want to work on our domain and our range for our new function, as well as write our rule. So as you can see from our bottom, our rule is that we're going to have x stay the same and y is going to become negative 4y. That's why I like writing it into the table, because it'll help us write our rule in the end. So now we need to write that domain. As you can see, for our x values start at 0 and they include it, which is why we do a square box, and they keep going forever, which means that I'm going to put infinity. The range, we start off at 0, and it does include 0, and it keeps going negative forever and ever, so we put in negative infinity. And our next video will contain our next example.